Hi everyone, my name is Ben Gamble and welcome to my talk on going Async API, the good, the bad and the awesome. It's a somewhat synchronous journey through our implementation of Async API on our Open Data Hub. So just starting off with a bit about me. So to start off with, I'm head of developer relations at Ably Realtime, a real-time pub sub message broker. I'm the sort of person who makes everyone read the Phoenix project. I like cool things, and I very rarely pass an API by which I don't want to start poking at. And particularly with initiatives like Open API, this makes it really awesome. So what is Ably, I suppose, and why am I kind of talking about all this? So Ably is a globally distributed data streaming network. We do pub sub. We do lots of cool stuff, but that's a wall of text. So yeah, pub sub. And we allow people to publish and subscribe in bidirectional channels from almost every device you can imagine to almost any other device you can imagine. We are really fast, which is possibly our biggest selling point, which is that we have low round trip times via all the usual clever routing you can imagine through the backplanes of various cloud service providers. And we really do a lot to try and maintain reliability and ordering and availability through all of this. We can do some rather fun things like the usual 5+ nines of reliability of delivery, but up to 8 nines of reliability when it comes to data integrity. And all this is basically based around the idea of having a series of globally distributed clusters in multiple different data centers. And on top of that, doing the whole edge thing. We have over 200 edge presence points, and we always try to deliver everything we can get through the network. And I suppose then that's just who we are and who Ably is. And I suppose the next real question is is managing these APIs hard? Because that's what we're all about here at this conference, is about APIs. And are they hard to manage? And the answer is yes. Yes, they are. Because we want people to use them. And, Kong, AWS, Nordic, and Swagger have invested a ton of money to make these things better. And they make a lot of money making them better for good reason. It's really, really hard to manage these things right. And, it's so important. We actually got an initiative out of it. Open API has continued to flourish over the years and has really driven people to create the right sort of data that people can read, that can generate documentation for itself and is ingressible into other tools to allow you to actually generate code and start using APIs faster and better. So the real question is, what happens when you need more than just REST? So REST is great. It's stateless. It's very much driven by wanting your data. You push, you pull, and you get what you need. But when you want to go more than that, we have a problem. If you want to support real-time data, if you want to support data which is asynchronous, you need more than just a REST API. And this is where it gets a bit complicated because we enter the fragmentation of protocols. We have everything from devices that stream on raw UDP to things that just use REST themselves, and everything in between, all the various TCP-based protocols like MQTT, the HTTP other standards like SSE, and some other things like WebSockets. And it gets complicated because there are a lot of languages. So, OpenAPI is brilliant because it, of course, supports all the languages you want to use REST requests on. But when you have multiple protocols and multiple languages, you start multiplying up the problem. And particularly from where I sit, the problem comes from the following thing. We built a hub. We wanted data to be open, and we want to kind of drive forward this next wave of the event-driven ecosystem. And for us, it was basically, we realized that we needed to make sure that data was available for people to see what happened, and also because it should be free. So the Ably Hub is a literal collection of streams of open source data, which we provide free of charge to anyone who wants to use them. Get an account, subscribe, and you'll get a feed of data. And it's all well and good, but there's a lot of it. We have 15 data sources, each with a number of channels in them. Channels are analogous to topics in Ably vernacular, so I will use the two terms a bit interchangeably if you're familiar with pub sub standards. So each of these things has a variety of channels, and of which some of them go into the hundreds. the one there of the London tube schedule, has a literal channel per tube station. This means that as you try and actually, enumerate all these channels to work out what is actually there, you have a serious problem because it's a lot of work and it gets very difficult to manage. So the question then is like, why do we care? Data is open and free, and we want to make sure this data can get to the people, because it's not really relevant if it's all behind closed doors, you have to pay for everything. And that's not what we wanted with this. We wanted to make sure that it was available to everyone. And of course, it's in a lot of protocols. We have our own protocol, which is effectively in the real-time world, a WebSocket-based protocol, but we also support HTTP. We allow for SSE and MQTT, or at least a subset of it. And we support 9 languages across our platform with our SDKs. But if you start multiplying these things together, where 15 sources, an average of 10 or so channels per source, 9 languages times 4+ protocols, you start getting into some really fun geometrical progression of scaling here. And this is where we kind of have a problem, because without doing something, what can we do to manage it? And this is where we kind of had to start thinking, like, what else is there? Now, the thing is, right, as with everything, we're never alone. And everyone else has had a similar problem before. Everyone who has presented an API, who has a public-facing API at some point, has thought, what can we do to manage it? And Open API is a very common way to deal with it these days. Was it perfect to begin with? No, but it's getting to the point where it's just ubiquitous. And that's brilliant, because it means there's now a standard which people can understand. So what happens when you want to do things which are not just, REST? And, a heady brew of crazy came to the rescue. So based out of ideas at Hitch, combined with thoughts from the Open API initiative, and also the way Ramel was starting to really start specifying proper machine readable specifications, out came Async API. And it is quite the brew of interesting things. I call it a brew in this particular circumstance because it is a genuine mixing of things. It's the idea of saying we must be able to have more than one thing in more than one way from more than one provider. None of these things really are good enough if they stand alone. So you end up with what can only be described as a lot of different things under the Async API banner. These are everything from what you'd expect from documentation generators to code generators to verifiers and other things. And of course, it comes back to a machine readable specification. And this allows for a pretty dry martini of code. Machines love it, and they will use it any day of the week. But the really valuable thing is it allows for consistency. The one big thing about async code, and particularly with message-based systems, is you don't necessarily know what the data is going to be over time, because you don't know what it is until it receives it, and it can be different every time. Messages can contain, by definition, variable data. And what you can do with Async API is you can actually specify the structure of this down to the typing. Not all types are supported logically, but everything from integer to enum to string to float are actually a supported and therefore verifiable type. It is up to the generator how this is actually used and what you do when something does not conform to the specification, but it does allow you to test it. And this is where we get to the kind of critical value proposition for us. Was we needed to be able to both give somebody a way to read our data and give them the way to know that the data is correct, to verify it's correct and discard spurious things, but also because we want to share any data we can get hold of. If you give us open data, we will take it and share it. And we want you to be able to give us a specification for that data. So from that, we want to be able to verify the data is good before we stream it. And specs allow us to do this. So then we get to the thing of what are we actually trying to do? So we need to build generators. So Async API, as it currently stands, has a series of generators for the kind of known open async protocols. These would be things like MQTT and SSE. The problem, of course, is that we have our own protocol, which has been built after much research and much time and a lot of money invested to try and make something which is ridiculously reliable. Problem is, it's a bit complex. It allows for a very wide variety of things, including the ability to rewind through time and to get messages earlier than you connected, still maintaining synchronicity and presence, and other such advanced features you'd expect from a fully fledged pub sub type system. The problem with that is most, like MQTT doesn't maintain any of these things. Most of these open standards don't have a concept of presence, which basically means that as we try and went through the specs, we found that, to be honest, our protocol expects a lot from you because it gives you too many options in some respects. All these options are very valuable, but we came up with a thing which our generators are a bit lackluster for what the actual spec supports. Next thing we tried to do, which was in some respects even more fun, was actually generate specs. Because if you have if a spec is machine readable and can generate code, logically you can read data and generate a spec. So we tried this once again. It actually worked, which surprised us. The actual specifications are quite rigorous, and you can literally listen to a data stream for a while and gain a pretty reasonable coverage spec of it. The problem is there is no guarantee of completeness because of the way both our network and MQTT work in this case. You have no way ahead of time to know what channels are going to be sent along unless you have predefined from the source. If they're not predefined from the source, you can't guarantee that you have all the information. Not to say we're not going to try and continue down this road. It's just that they will be known incomplete. One day maybe we'll have the ability for effectively a spec to be transmitted on the wire as well, and that can then be read in. For our system, at least, it works pretty well, but it's a little bit off kilter of the way the actual kind of general specifications work, and it relies on the fact that our SDKs can do quite a lot of magic behind the scenes. So where do we kind of go from there is like, how about other people's specs? So we have an open hub, as previously mentioned, and we are really keen to go and find as much open source data as we can get and put it on there. We have the data sources you saw earlier. They range from REST APIs we behind the scenes poll to MQTT sources to some other things. And the general thing is that we spent a little while looking around for other people's specifications and then have them ingested in and have them as products, because we want to add as much as we can to this hub because we think it's useful. We want it to be open. But what we ran into were two kind of big problems. The first one is wildcards, and the second one is delimiters. Wildcards is MQTT's way of subscribing to multiple channels or topics at the same time. You can subscribe to all devices under a certain name at the same time and get all those channels being received in one place. And what that is, though that is really powerful, it's not something we in our network directly support. Our ingressor by default sorts it all out and means that all things get broadcasted correctly, and it handles it quite nicely. But by default, we also directly absorb MQTT. And if you don't go via the ingressor, it means that we have the problem with our namespaces don't match, same way as our delimiters don't match. And this is actually goes a bit deeper, because across all the different ways you can send message-based data, there isn't a standard delimiter. There isn't a kind of lingua franca that says this is the delimiter of a channel or a namespace or the delimiter of a topic. That doesn't actually exist. There is no one specification that says this is a delimiter and then define it in 5 different protocols. That doesn't exist anywhere. Instead, every single real-time protocol I've seen does something subtly different. Nearly always they're within a certain kind of, should we say, ballpark. But we support regex on our channels, which means you can send a regex in and it'll get the regex of those channel namespaces back. The problem is some of those regex things are actually delimiters in other specifications. So we have this kind of problem where that because we can't directly convert to a truly generic, there's no GTP3 equivalent of real-time topic management. So we have the fact that that doesn't exist. So we have some interesting ways to work around it, but they're not perfect. And the last thing, which is in fact the saddest answer, is because Async API is new and young, there aren't actually that many specs out there. I want to be proved wrong, by the way. And if there's any kind of like open source data which has a spec attached and we've missed it, just send it to me. We will share it immediately as fast as possible. We want these things and we will host them up. But we found a few, but they had the usual issues of early stabs in this direction are often incomplete, not the best use cases, don't allow us to really demonstrate the power of the actual specification itself. And what have we done, I suppose, is the next real question. So we've learned a lot, and we had to dig a lot. This is a young project, and it has been built It's been built with remarkable rigor, and there is a lot of tools for it. And the learning that was required was pretty vigorous. We kind of set out with the high-minded expectations of we'll try a bunch of things and not much will work. But we were pleasantly surprised by the amount of things that actually worked. Like reading from a spec and just generating our own code worked surprisingly well. Generating SSE code from specs we've written for our own systems worked perfectly first time, to the point of where we were all surprised, which is wonderful because it works in all the different languages we wanted it to work in. So then as we went through it all, we kind of, worked out what we had to build. So we built generators for the Ably SDK. Because it is quite a powerful SDK, it can do a lot of magic to make it a bit better. But we started going further because we can start to do things like define the way permissioning works based on the channels specified in specs. And so as we kind of went forward in this, we built a lot of tools. And we are releasing these on our GitHub in the next few weeks because right now some of them are a little bit too alpha to be kind of truly verified. So they're in a state of current testing and hardening. And the idea is to release them over the next few weeks, fully open, of course, on as permissive a license as we can for anyone to use in any circumstance. And also, we wrote a lot of specs, and I do mean a lot. We have written a spec for every single product which you have on the hub, but they're in various levels of readiness. So as we found that some things did not work, we actually upgraded our systems behind the scenes. We actually now use specs behind the scenes for a lot of our actual ingression because it allows us to type check what we're getting. Not all these data sources are perfect every time. So we now use the fact that we've used Async API to generate. We've written an Async API spec for some of the data sources. We have then used that spec to verify the data we get from the source, and it's actually improved the quality of our actual product. Now, it's interesting because we've now put up at least a few specs on our hub, and as I said, as time goes on, all the hub products will have a spec. And hopefully, even the ones which are added which don't come with specs will have a generated spec for them. That project is still in flight, but we hope to be reporting back on that as soon as possible. And what gets really interesting then is the fact that what we can try and do is effectively read a data source, generate a spec from it, host the spec up, allow someone else to just ingest that data source with a press of a button, and literally on a website be receiving an SSE stream, which at no point was not machine read. We've almost got to the point now where things without a single line of code can indeed do all the magic. So a few things before I show you some stuff about this is some shoutouts. So as with all cool things, it's all about standing on the shoulders of giants. And here is my little Drift compatible team of awesome. Fran Mendez, a big shout out to you for actually chairing the whole Async API effort, for taking the risk to go out and build it. and for being a wonderful resource and genuinely being really supportive. And then Tom Camp, who has been my wonderful engineer, who's been driving a lot of this forwards and putting up with my madness and ideas about how we should try and do it. He's been the mastermind behind our open source hub since its inception. And he has done a wonderful job making sure that we actually have some specs ready to show you today. So I'm just going to hop out of full screen now and actually take you straight to our website so you can see at least one of the specs is here. So this is real-time CT transit data from somewhere in Connecticut. It's a GTFS spec, which is another open source specification for travel data. These are the various languages we support on our own SDKs, but also via HTTP, SSE, and MQTT. But the point is that, you know what? No one wants type code if they don't have to. We want that lovely dry martini effect. So here is the Async API spec. Here is all the definitions for all the various points. You can subscribe using AMQP, REST, MQTT, secure or not. And that's the thing. Like, we can specify the channels, we can specify arrays, strings, and currently, depending on which generator you use, you can actually control the kind of messages and errors that come out, because these types are hard enough to allow that. And that's something which has been missing from both our own systems and every other real-time messaging system I've used in the past, outside of something horribly hard like Protobus, is that you can't type check stuff. You can't be 100% sure that what you sent was what you and received was exactly what you expected. And this gives us a way to do it. And it is quite wonderful. Specs are, of course, long, but machine readable means machine readable. So you don't really need to read this. Documentation can be auto-genned, and everything else will just work. So please, do what you can with this. We'd love to see some demos. We have a series of our own demos based on this data, which are like running on Mapbox maps and showing the kind of the usual fish tank effect, but we'd love to see what you come up with. Anything which is cool, we'll of course host for free to see it and run it to show basically so the world can see. And this data is of course free to use. So please sign up and download and just plug in and see what it does. So and now I have some time for questions. Sorry, scroll. So I'm scrolling up through some of the questions here. Yes, drift compatible. That is indeed my thinking as well, Patrick. Someone actually beat me to pasting the URL. The MQTT specs, I will go to that now. Sorry, I hopped through a bit and I will zoom in a tad. So you can just specify out which they are. We only support a slightly earlier version of MQTT, which is because it's just how our adapter works, but it is complete to receive. It's a little bit different to send. And this is indeed fully open, and the code behind all this will be open soon. So the ingester for the hub, the spec generator, once it actually is complete, will be open. The way to do type checking in the ingesters will be open as well. And also our generators for our own protocol and anything we have done to the current generators will also be open. Most of the cool thing is it just really works as you might think it does. Just kind of scroll through a little bit further. Kind of the fun things here are because the channels or topic definitions are included, you don't need to wait for the inevitable fact of that channel might not exist ahead of time. Now, with MQTT, that's less of an issue because of wildcard subscriptions. But with something like SSE, if you don't know it in advance, you're not listening to it. And that's not useful. It means that you are going to miss stuff without knowing the specification ahead of time. And writing out the few, potentially 1,000 potential channels that could exist for this is just too difficult. So, combination of some magic behind the scenes at Ably will sort of dedupe it all for you down to one connection. But also, even in the wild, it's really, really powerful to know what should and shouldn't be there. So I'll just scroll back up to the stuff here. Any further questions? If not, and you have any kind of cool open data you think we should share to the world, any cool specs you think we should try reading or generating more code for, or any cool ideas of what you think we should do with open data, please tell us. We really want to make this thing go everywhere, because it is free. It is like, you do need an account, yes, but it is a free account. We don't take any details from you to do that, and all we need is people to use this data, and we'll keep supporting it. Okay. Well, if there are no more questions, I'll give it another minute. Okay. Well, thank you very much for listening. I hope you have a wonderful day, and please send us any open source data you have. Oh, wait, someone's actually messaged more, so I didn't scroll far enough. Oh, right. Hooking into Kafka. We actually have a Kafka supporter already behind the scenes. If you actually want to use it, talk to us. We'll show you ways we can actually stream straight to it. Sorry, I didn't scroll far enough down on the chat, but yes, I think that is everything. Okay. Bye for now.